Since we skipped chapter 5, I'm not surprised that you guys had a question on 80, dealing with inverse variation. So, alright, so in problem 80, you're dealing with inverse variation again. And it says, find an equation for the heights in terms of the volume and the radius. Use K to represent the constant. The height of a cylinder varies directly with volume. So the height varies directly with volume. So we can think of these as being directly related. And the height varies inversely. So it's going to be 1 over the radius squared. Whatever the radius. And we can think of this as our constant. So if we're going to combine these two ideas, we'll have H equals K times V over R squared. So it's direct variation means they'll be equal to each other. Inverse variation means you're going to do the reciprocal. So you see that H and R squared is below. So as H gets bigger, R squared gets lower. Whereas here, H gets higher, V gets higher. Okay. So this is your equation. And then it asks, when the volume is 20 and the radius is 2, and the height is 15. Okay, so let's back up. So 15 is equal to K times our volume, which is 20, all over our radius squared, which is 2 squared. This will be 15 equals 20K over 4 times 4 times 4. We get 60 equals 80K. Actually, nope. 60 equals 20K, because these will cancel. Divide by 20, divide by 20. This allows us to solve for K. K is equal to 3. Now that we know that K is 3, we can go back to our original equation. H equals KV over R squared. And we substitute in 3 for K. This would be 3 times our volume 10. All over our radius with a radius of 3 squared. So it'll give you 30 over 9. Your height would be 30 over 9, or we can simplify to 10 over 3. Alright, so that's 80, inverse variation. Wouldn't worry too much about that right now, but it's an intro to kind of some more things we'll be doing in Condo's class. I think the other number you guys had questions with, the other one you had questions with was 96. So I'm going to go ahead and do that. 96. No, I think it was 95. Excuse me, 95. So 95. Suppose alpha is in quadrant 1, and beta is in quadrant 4, such that sine of alpha is equal to 2 over 3, and cosine of beta equals 1 over 4. For this problem, we got to answer a bunch of questions. We need to draw triangles. So let's set it up. So we have quadrant 1, quadrant 4. I got my right angle, got my alpha, my beta, and then we know a couple things. We first know that sine of alpha is 2 over 3, which means my opposite over my hypotenuse is 2 over 3, and then cosine of beta is adjacent over hypotenuse, so that would be 1 over 4. Now we need to solve for the missing sides. So we get 2 squared plus b squared plus 3 squared. And we get b equals the square root of 5. So for this triangle, we know that our adjacent is square root of 5. And then for our other triangle, we're going to have 1 squared plus b squared equals 4 squared. So b squared will equal 15, square root, b equals rad 15. So this is negative rad 15, which gives you that side. Okay, we've done A and B. Now let's go on to part C. So CS sine alpha plus beta, and this will equal sine alpha cosine beta. Use the same sign plus cosine alpha sine beta. Sine alpha based on our drawing, well, we have that from the information, 2 over 3. Cosine beta, we know that is 1 over 4 plus cosine alpha. You're going to take your adjacent over your hypotenuse, which is rad 5 over 3 times sine of beta, which is negative rad 15 over 4. So this will be 2 over 12 plus what is this, rad 65, negative rad 65 over 12. If we factor tree this down, we get 65, break it down, 5 and 15, break it down again, 5 and 3. Here's your pair, so this whole thing is equal to 3, 5 rad 3. So we would get 2 over 12 minus 5 rad 3. Question D is the same thing, except you're using cosine of alpha plus beta instead, so a different identity, different trig functions.